Here we have an Asus laptop. It came in for no power. What's new? Every day, every single day. Asus, Dell, MSI. Asus, Dell, MSI. We have a couple of Lenovo's, but mainly Asus laptops. We already disassembled the board right here. I do not know the model, but I'll figure it out and write it in the title. Right now the charger plugs in right here. So I'm interested in checking out the power MOSFETs, and most likely they are in this area here. So let's take a look and see what's going on. I'm looking for the current sense resistor right there, and I'm gonna test at the current sense resistor or on the drain of the MOSFET. Meter in diode mode, and let's measure right here, and we have a short. Anytime we have a short, we're gonna grab our voltage injection tool, and we have it set to 1.2 volts. Let's just make it 1 volt even, and we're gonna inject 1 volt at the shorted area of the MOSFET right over here, and the ammeter is drawing 1.88 amps, so we do have a short. Now when we inject voltage here at the shorted area of the MOSFET, whatever component is shorted to ground will get hot. How do we know which component is getting hot? You can do it the old-fashioned way where you feel with your fingers, and I do not recommend that, because unless you have a lot of time on your hands, and of course you have to have very sensitive hands, because sometimes the heat is very minimal and very hard to detect. What we're gonna do is use a thermal camera to see what's getting hot on the board when we inject 1 volt at the shorted area of the MOSFET. I just want to get an overall view of what's going on the board. That's the board right here. And let's inject 1 volt at the shorted area of the MOSFET and see what's getting hot. All right. What is getting hot? I see a heat spot all the way on bottom of the board. But heat is not coming from this side of the board because heat looks diffused. It must be coming from back of the board. All right, so I just flipped the board. Right now, since I flipped the board, I cannot inject voltage anymore. So what I need to do is inject voltage on front of the board. I need to flip the board, and then I need to look at the board under a thermal cam. You need 16,000 hands for this, but let's try to do it with 2 hands. I have my ground probe that's connected to one of the screw holes, and the MOSFET that was shorted to ground is this one here. So let me see if I can point that probe onto the MOSFET, and then I have a contact, and then we're gonna do this. Oh, look at this. Look at this. Wait. Let's see if you can see it. Right there. Right there. Let me switch over to the thermal cam so you can have a better view. That is the component that is shorted to ground. Okay, and that looks like the 3rd cap from the left, based on what I can tell. I do not have a 3rd hand to pinpoint my finger on that heat spot, but based on what I can tell, it's the 3rd cap to the left, or from the left. Let's take a look at the area and see if we see anything obvious. So that's cap number 1. Any blown capacitors, any cracked capacitors, anything that looks right there. Right there, you see? Cap number 1, 2, 3, just like I thought. This cap does not look good. This one here. Let me quickly measure. We have a short, we have a short, and of course we're gonna have a short everywhere, because this cap is probably affecting other caps in the circuit. Now that may or may not be the cap, but what I'm going to do is start with this cap because it does not look good, and we'll take it from there. We always start with the one that does not look good, and this one is the only one that does not look good. Let's see, are we gonna get lucky? And I just want to cool the board a bit, because sometimes you get the wrong measurement if the board is still hot. The wrong reading. Okay, so let's cool it down a bit, and then we'll measure to see if we still have a short. And the short is gone. Look at this. The short is gone. Wow. We just pinpointed the source of the problem and the job is done. Somebody out there will say, oh, that was an easy fix. Define easy. What is easy to you? Because sometimes we get people commenting and saying that they need something more involved. What do you consider more involved? If we are able to find the fault quick, that's considered an easy repair. But to a person that cannot figure out the problem, it's a hard repair. So define easy. If you have the experience, everything is easy. If you are able to find the fault, everything is easy. When you are not able to find the fault, then it becomes more involved, because you are looking and looking and looking. You cannot find the fault. Then to you, that's a more involved repair. Just like a customer who came in a few days ago with a dead laptop. Laptop does not power on. And he said, I want you to fix this laptop for me. I'm sure it's an easy fix for you. I'm sure you'll replace one component and you'll be able to fix that laptop. He's telling you all this so he does not have to pay a lot for the repair. I told the customer, it's an easy fix for me, not for you. That's why you brought it here. You are paying for experience and not for me to replace a part, whether it's a capacitor, MOSFET, or whatever the case may be. 90% of the repair is finding the fault, and the other 10% is the soldering part. That's why I say define easy. For a person who cannot find the fault, the repair is considered difficult. But if that very same person gave the device that he could not fix to somebody else, and he watched him work on it, and that person was able to figure out the fault in 5 minutes, that person will say, oh, that was easy. It's easy on him because of the experience. He knows how to locate the fault quick. Experience did not come overnight. You build experience over the years. I use my experience that I built through the years to figure out faults quick. That's how I make money. Instead of me spending 2, 3, 4 hours working on one board, I spend 5 minutes and I charge the same amount because I paid with time and long hours to come to that point where I can now fix a board in 5 minutes. Let's get rid of that cap. And we're gonna replace it with a 10 microfarad capacitor. And a lot of people ask, how do you know it's 10 microfarads? How do you know it's 10 microfarads? I mean, when we work on 5, 6, 10, 20 laptops a day, over and over and over, we figure it out. The first time I wanted to figure this out, I removed a similar cap, one next to it. I measured it. It's 10 microfarads. So now I know anytime I get a similar laptop, then the value of the capacitor is 10. I'm not a psychic and I cannot just make up numbers, but it comes with experience. Just like that. And let's solder a good cap right over here. And that's it. The job is done. The job is done. Let's clean up. And then we're gonna test to see if everything is okay now. Let's flip the board and test that very same MOSFET that was short into ground and see, do we still have a short? If not, then most likely the job is done. We still have to test, of course. We're gonna test right here. .42. voltage drop. Awesome. We do not have a short anymore. So there's a 99.99% chance that this laptop is going to work. We're gonna reassemble and I'll be back to finish the video. We reassembled the board and the laptop is fully functional. We already tested, I had no doubts, but I wanna show it to you so we can complete the video. Let's plug it in, press on the power button, and ta-da, working. Automatic repair, some type of issues with the operating system, but that's not why this laptop came here. So that's it, the job is done. We're gonna invoice and mail this back to the customer. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions and we'll do something else in the next video.